piece of most compounds is called a molecule. Every molecule of a compound has the same number and type of atoms and the same structure. Since all the molecules of a compound are identical, every sample of this will have the same ratio of the elements and therefore have the same chemical and physical properties. Let's look in detail now at formulas. Formulas describe the makeup of compounds. A compound, we know, is a distinct substance that is composed of two or more elements in an unchanging ratio. Each element is represented by its letter symbol in the formula. The number of atoms of each element is written to the right of the element as a subscript, so that means a small number written below it. If there is only one atom, however, in the molecule, the one subscript is not written. And we're going to be learning very soon about something known as polyatomic ions. When we come in contact with them, and there's more than one polyatomic ion in the formula, then they are placed in parentheses. So let's look at two examples of formulas that we've already seen. Here's water, 2 hydrogen and 1 oxygen atom. And here's the structure of water. It has this bent structure. Oxygen is always in the center, and 2 hydrogens are on its side. And here's table sugar. We've already seen that it has 12 carbon atoms for 22 hydrogen atoms and 11 oxygen atoms. And here's a molecule of sugar right here, dissolved in water. Here are the little water molecules, and here's sugar. It's hard to see those black carbon atoms, but they're buried underneath all the oxygen and hydrogen in the sugar atom. Now, when we write formulas, there is a specific order that we need to follow. If the compound has metals in it, the metals are always written first. So here's an example, NaCl. So that's why it's very important to know where the metals are on the periodic table and to be able to identify a given element as a metal or nonmetal. Because if it is a metal, it's going to come first in the formula. And then the nonmetals are written in the order from table 5.1. And this is something that you might want to write down on your card or have handy when you're doing your homework or your homework quiz. C comes first, then P, then nitrogen, then hydrogen, then silicon, iodine, bromine, chlorine, oxygen, and fluorine. Now there are some exceptions, and we'll learn about where those exceptions come up. For example, here's a compound where the oxygen is in front of the hydrogen. And this right here is what's known as a polyatomic, and you'll soon be able to identify those. But here's our example, CO2. Our carbon comes before our oxygen. And here's an example of CO2. Dry ice is the solid form of CO2 or carbon dioxide. And here are the little molecular models of carbon dioxide. The black is carbon, and it's a linear molecule. On either side are the 2 oxygens sandwiching the carbon. Now, we'll look at this in more detail, but I find that it is best to address this as many times as possible. When we are looking at compounds, there are 2 main types of compounds, what's known as molecular and what's known as ionic. Molecular compounds are made up of molecules, and molecules are nonmetals only. So that means we're looking only at elements that are green here, and then hydrogen, of course. Remember, the noble gases are nonmetals, but they don't form compounds. Ionic compounds are made of metals and nonmetals. They are also made of ions, and ions are fundamentally different than molecules. So the properties of ionic compounds are going to be different than those of molecular. So it's important that we can distinguish between the two. Ionic compounds always are made of metals and nonmetals. So we're going to be looking at metals, an element from this side, as well as elements from this side. So both sides of the periodic table will be ionic. So let's apply what we've learned about formulas. Pause the slide and see if you can write down the formulas of these 2 compounds in the correct order. And by correct order, I mean putting the elements in the correct order. So let's look at the answer here. It tells us that there are 4 oxide. Now this is a little tricky here because you had to guess that this was going to be an oxygen. This is an ionic compound because we have a metal and a nonmetal. And as I said earlier, these are made up of ions, and we haven't gone over the nomenclature or the names of these ions. So if you figured out this was an oxygen, you can pat yourself on the back or at the back. So our metal comes first, tells us that there are 3 of them. So the 3 goes as a subscript to the right of the iron symbol. And then oxygen comes after. And there are 4 of them, so we put a 4 subscript there. This one was a little simpler because the names of the elements are very clear. Hydrogen, carbon, and oxygen. And if we look back at our chart that's given in your book, carbon comes before hydrogen, and then oxygen comes last. So 3 carbon atoms, 6 hydrogen atoms, and if there's only 1, we do not put the 1 there. So if you got both of these right, give yourself another pat on the back. Now we will look at polyatomic ions in even greater detail, but let's look at how polyatomic ions apply to the formula. Polyatomic ions, of course, are ions. That means there's an unequal number of protons and electrons. It means that they actually have an overall charge. We don't care how it got that charge, we just know that it does have a charge. It's more stable that way, actually, and we'll learn why it's more stable in a few more chapters. Now the thing about polyatomic ions is they always stay together. This polyatomic ion is known as nitrate, and soon you'll know all the names of the common ones. Nitrate always has a nitrogen and 3 oxygens, and it will always be in an ionic compound with a metal. The metal will come first, and this will come second. Now, in this particular compound, we have more than 1 nitrate. If you have more than 1 polyatomic ion, they are put in parentheses, and the subscript, which has to be 2 or greater, goes outside of the parentheses. Here, we have another polyatomic ion, known as sulfate. Sulfate always is SO4, 1 sulfur and 4 oxygen. And as I said, you'll soon be able to recognize these polyatomic ions. There's not more than 1 in this formula, so no parentheses are needed. So what does this mean in the overall formula in terms of number of atoms? Well, it means that if we look at this formula, there is 1 magnesium and actually 2 nitrogens, because there are 2 of the nitrates, and 2 times 1 is 2. And there are a total of 6 oxygen, because there's a total of 2 nitrates, and each nitrate has 3 oxygens, so 2 times 3 is 6. So we multiply this subscript by the subscripts within the parentheses to get the total number of atoms of a given element. Over here, because there's no parentheses, we just count the subscript. There's 1 calcium, 1 sulfur, and 4 oxygen. So pause the slide and see if you can determine the total number of atoms or ions in one formula unit of each of the following. And by the way, let me just give you a hint here. This is going to be considered an ion. We haven't gone over this yet, so this is going to be considered an ion, and these 2 will be considered ions as well. And in the parentheses, these will be considered atoms. So don't fret about the atoms versus ions at this point. Let's just look at these and count them, and we'll check the answer in just a minute. Pause the slide and we'll see what you get. So as I said earlier, let's not fret as to whether these are ions or atoms. Let's just look at counting. So here this polyatomic ion, we know it's a polyatomic ion because it's in parentheses, and polyatomic ions always occur in ionic compounds, and we know it's ionic because there's a metal in it. Magnesium is a metal. If we look at the periodic table, here's magnesium over here. It's an alkaline earth, so it's a metal. Okay, now let's count. 1 magnesium, there's no subscript after the magnesium, and we're going to have to do a little math to count our atoms in our polyatomic ion, the total number, because there's more than one of them. So we'll take our subscript here, which means we have 2 of these polyatomic ions. This polyatomic ion, by the way, is known as acetate. So 2 times 2 means we have 4 carbons. 2 times 3 means we have 6 hydrogen. And 2 times 2 means we have a total of 4 oxygen. And if we add these up, we get a total of 15. Now let's look down here. This is a polyatomic ion made up of a metal. And these are rare, but they do happen. So there's more than one of them, so it's in parentheses. Here's another polyatomic ion, and there's more than one of it. So let's multiply our subscript by the subscript inside the parentheses. 3 times 2 means I have a total of 6 mercury. And by the way, you would know this is an ionic compound not only on the polyatomic ions, but also on the fact that mercury is a metal. And then let's look at this polyatomic ion. This polyatomic ion is known as phosphate. 2 times 1 is 2, and 2 times 4 is 8. So when we add these together, we get a total of 16. If you got this right, give yourself 2 pats on the back.